So for this problem, it states a communication line uses a shield twisted pair STP cable that has a velocity factor of 0.7. What is most nearly the wavelength of a 2 gigahertz signal traveling on the STP cable? So first, well, the formula for wavelength is C over F, which C is speed of light, basically like the velocity propagation, over frequency. So this is what we're trying to solve for. So what's given to us is the velocity factor of 0.7, and velocity factor, well, the formula is, well, it's represented as K. Let me write that a little bit better. K. V over C. So basically we're going to try to substitute this into here just so we can get one uniform equation, where we can just plug in everything that we have, which is the frequency, K, which is the velocity factor, and speed of light is just a constant value. So once we plug it in, we're going to get the wavelength is equal to Kc over F. So now that we're given a uniform equation here, we can, with everything that's given to us, so we have velocity factor, speed of light, and then now the frequency. So great. So now we just plug everything in. So K, which is a constant, there's no unit, 0.7, times the speed of light, which is 3 times 10 to the 8th meters per second, which is also like given to you in the formula sheet, but it's also good to like kind of just remember that. It saves you a little bit of time. Over 2, well, it's gigahertz, so it's going to be times 10 to the 10th. Times 10 to, I mean 9th, my apologies, hertz. And then once you plug that into the calculator, you should get 0.105 meters. And that's the wavelength. That's basically traveling at that specific, at 0.7 velocity factor with the frequency of 2 gigahertz. All right, and now on to the next question. So basically it's saying calculate the minimum sampling rate for perfect reconstruction for the following signal. So basically, I'll just rewrite these. Signal sine 400 pi t plus 30. So in order for us to find the minimum sampling rate, the formula minimum sampling rate is going to be 2 multiplied by the bandwidth. So for us to find the bandwidth, we kind of got to put it in this formula into like the generalized way, which is sine of 2 times f in times t, and pi, 2 pi. Let me rewrite that because that's really close together. I don't want to confuse you. All right, 2 pi f in times t plus the angle. So if we kind of match this up, so we have 2 times Fn. So in this case would be 2 times 200. So it'd be 2 times 200 pi t plus the angle of 30 degrees. So for us, the bandwidth is 200, this value right here, Fn. So the minimum sampling rate is going to be 2 times 200 hertz, which gives us the sampling rate, minimum sampling rate, that would give us perfect reconstruction. It's going to be at 400 hertz. So yeah, not too bad of a problem.